Hey everybody, just want to make a quick video about worksheet 2.2.2 number 3 for Physics 11H. These type of questions are real common on the Regents exam, and I know we've talked about it in class, but I just want to just make a little further note on this, okay? So, remind you kind of how to do this type of question. I'm going to post the solutions here as well very soon. They're done. I just want to wait till closer to class time. But anyhow, gravitational force of attraction between two objects would be increased by doing what? So the way I always think about this is, okay, we're comparing original force of gravity equation, Fg equals g m1 m2 over r squared. And we're going to make changes to it and see how that affects the force, right? So I often say, okay, that's Fg, and then we're gonna have Fg nu, or Fg prime. Let's call it Fg nu, is what I did on the written solutions, right? I had to do this for quite a few of them on the homework. So then we're asked, okay, doing what changes what? Fg nu. So it's gonna be g m1 m2 over r squared. Let's say, you know, we're comparing what's different between the two here. So g is the same for both of them. That's never going to change. You can't change g. So really what we're changing is the product of m1, m2, and r squared. m1, m2, and r squared. So I'm going to kind of represent this a little bit differently. I'm going to write it as, you know, I'm going to kind of get rid of the g's in both of these and look at how changing the masses and the radius affect things. Okay, let me just get my focus lock on here so it's not trying to refocus. Okay, so I represent this. I just give generic numbers here. Let's say this is m1 is 1, 1, and the radius is 1. So it's 1 times 1 over 1 squared. All right, and that equals 1. And g is just some constant out in front. I'm going to ignore that. So let's look at what we can do to this equation now. All right, so for number 1 on here, right, if I double the mass of both objects, okay, so now it's 2m and 2m. So I increase both things on the top by a factor of 2. All right, so I go 2 times 2 over same radius, 1 squared. That gives me a factor of 4. So by doubling both masses, I've increased the force of gravity by 4 times. Cool. So definitely number 1 will increase the gravitational force. Let's check the other ones just to see what happens, okay? So now the next one says doubling the distance between the objects only. So I'm going to leave the top, 1 times 1. I'm going to double the distance between them, so that means make them farther apart. That's going to make the force go down. So that's 2 now on the bottom squared. So that's 1 over 4. So the new gravitational force now is 1/4 of the original gravitational force. All right, and again, what I'm doing here is I'm just representing these equations to figure out with ones and that sort of thing, just to figure out by what factor the gravitational force will change. So answer 3 says doubling the mass of both objects and doubling the distance between the objects. So I'm going to double the mass of both objects, so 2 times 2, you know, parentheses maybe might help keep this organized a little bit, times 2, and I'm doubling the distance as well. So I've increased the mass, but increased the distance as well. So increasing the mass will make the force stronger, but increasing the distance will make the force weaker. So 2 times 2 over 2 squared is 4 over 4, right? 4 over 4, that's 1. So in fact, that doesn't actually change anything by doubling both masses. So you get a factor of 4 increase on top, a factor of 4 increase in the bottom. It's what we call a wash. It's a wash. And then number 4, doubling the mass of one object and doubling the distance between the objects. So I'm only doubling one of the masses, so it's 2 times 1. And I double the distance, so I get a factor of 2 on the top, factor of 4 on the bottom. All right, so it's 1/2, so you get half of the original force. All right, that's one way I like to do these. You can also leave the variables in there and just make them like 2M, 1M, and that sort of thing, which is kind of the way I did it on the solutions here. It's always good to see a couple different representations of the same problem, so you can have different ways to do it, pick the way that you like best. Someday I might have to just move this light back a little bit in order to kill that glare. We'll see in future videos if I get around to doing that. All right, have a good one, guys. Talk to you later.